Solving quadratic equations using the quadratic formula. This is part 2. All right, example 2. In British Columbia, Canada, the number y of purple martin nesting pairs x years since 2000 can be modeled by the function. When were there about 1,000 nesting pairs? All right, so first we have to kind of understand the problem. So they're giving us a quadratic equation, and they're telling us that this represents the number of purple martin nestings after the year 2000. Okay, so that's important. So this is for after the year 2000. So 2001 would be 1 year after this. 2010 would be 10 years after this. Okay, so that's important to know. Also, we need to know that we're looking for when were there about 1,000 nesting. So that means we need to use the model to determine when there were 1,000 nestings. So basically we have to solve the quadratic equation for x when y equals 1,000. All right. So go ahead and set up the equation. So we're going to say we want to know when there are 1,000 nesting pairs. So 1,000, when does that equal 0.63x squared plus 51.8x plus 144. All right, so this is a quadratic equation. So we have been working with the quadratic formula. So if we want to do that, we have to first put it in standard form. So we're going to have to subtract 1,000. We got to set it equal to 0. So we're going to have 0 equals all of this stuff again, except now our constant term is going to be 144 minus 1,000. 144 minus 1,000 is negative 856. All right, so now that it's in standard form, we can determine our A, our B, and our C. All right, now we just need to plug it into the quadratic formula like before and solve. So we're going to have negative B plus or minus the square root of B squared minus 4 times A times C over 2A. All right. Then we have to simplify under the discriminant. Let's see if I can do that in one big step. All right. Got everything cleared out. I don't need to be graphing right now. I just need my calculator. All right, so remember the discriminant is the part underneath the square root. So I'm going to do 51.8 squared. And then let's go ahead and see, well, let's go ahead and do the whole discriminant at the same time. So minus 4 times A times C and under the square root, that's going to give us 48, 40, 36. And then we're going to do 2 times 0.63. So 2 times 0.63, and that gives us 1.26. All right, now we have to take and figure out which solution. We're going to have two solutions, and let's put approximately because I don't think these numbers with decimals are going to come out to an exact answer. So we're going to have x, so we're going to have negative 51.8 plus the square root of 4840.36 over 1.26, and we're going to have the other one, which is 51.8 minus the square root of 4840.36 over 1.26. All right, so this is going to be let's use parentheses to make sure it knows I'm working on top of the fraction. So 51.8 plus the square root of 4840.36. Let's get out from underneath the square root. Close our parentheses so they know that that's the top of our fraction. Then divide that by 1.26. And that's going to give us about 14.1. So this one's going to be about 14.1. And remember, that's years past 2000. So we'll come back to that in a second. Let's go ahead and do the second equation here. So we've got negative 51.8, and this time it's going to be minus the square root of 40.36. Again, come out from under the radical, close that off, and divided by 1.26. Hit enter. And that's going to be negative 96 about. So we can say we're not going to have a negative number for years, for a number of years. So we know that that's going to have to be the first solution is going to be the one that makes sense. So we can say that about 14 years after the year 2000. So in the year 2014, in 2014, there will be about 1,000 nesting pairs. All right, so again, you could take this number here and you could plug it into the equation and see if it does in fact equal the 1,000. It's always good to plug that number in and check it. You also could take your calculator and plug this in as a system of equations. So you could plug in y equals 1,000, and then you could plug in y equals 0.63x squared plus 51.8x plus 144, and you could find the intersection point of those two. It should be right around 14.1. And again, remember, that is in years since the year 2000. So to figure out when the purple martin is going to have about 1,000 nesting pairs in British Columbia, that would be in the year 2014. And since the year 2014 is now in the past, you could actually look up that data and see if that's accurate. Determining the number of real solutions. All right, so if you remember if you find the discriminant, that's the number under the square root. If that number is positive, you have two real solutions. If that number is equal to 0, you have one real solution. And if it's negative, you have no real solutions. So we can quickly find out how many solutions we have by simply doing b squared minus 4ac, which is the discriminant. That's the part under the square root. So again, we have to determine our a, our b, and our c. And this time, instead of doing the whole quadratic formula, we're just going to do b squared minus 4ac because that's the discriminant. All right, so we got 8 squared minus 4 times 1 times negative 3. So we're going to have 64 minus 4 times negative 3 is plus 12. 64 plus 12 is 76. Since that is greater than 0, that's a positive number greater than 0, we have two real solutions. And that's all we wanted, was to figure out how many solutions we have. So two real solutions because the discriminant is positive. All right, for B part, first thing we have to do is put this in standard form. So we've got 9x squared. We have to subtract 6x to the left-hand side. We have plus 1 equals 0. Once we do that, we have to determine our A, our B, and our C. And then we have to find the discriminant. So again, we're doing b squared minus 4ac. So we're going to have negative 6 squared minus 4 times 9 times 1. So we're going to have 36 minus negative 4 times 9 is negative 36. And then that's times 1. So that's just still 36. 36 minus 36 is 0. So that means we have one real solution. So quickly you can figure out how many real solutions you have by simply looking at the discriminant. That is important to know. Please make sure you commit b squared minus 4ac as the discriminant to your memory. Example 4 says finding the number of x-intercepts of a parabola. Okay, the x-intercepts are the solutions. So again, we're going to be looking at something that, like, basically the same thing. We need to find the number of real solutions that we have, because those are going to be your x-intercepts. So that would be your discriminant. So we're going to have b squared minus 4ac. So we got 3 squared minus 4 times 2 times 9. All right, so we've got 9. 8 times 9 is minus 72. That is going to be a negative number. So negative 63 means there are no real solutions. There are no real solutions, which means there are no x-intercepts. So the discriminant can tell you how many real solutions there are, which also determines how many x-intercepts there are. All right, the self-assessment, find the number of x-intercepts. So I want you to pause the video, take time to do this, and then come back to see if you got it correct. All right, first determine your A is 1, B is 12, C is 36. Plug it into b squared minus 4ac, and then you simplify and you get 0. When you get 0, you know that if your discriminant equals 0, you have one real solution. That means the number of x-intercepts on the graph would be 1 x-intercept.